Good morning. We are back for chapter 3 of George's Secret Key to the Universe. If George had thought the kitchen was untidy, there's another one of those prefixes, then this next room was in a whole different dimension of messiness. It was filled with piles and piles of books, stacked up so high that some of the wobbly towers reached almost to the ceiling. As Freddie charged right through the middle of the room, notebooks, paperbacks, leather-bound tomes, and bits of paper flew up in a tornado around him. Crazy. "Catch him!" shouted Eric, who was trying to drive the pig back toward the kitchen. "I'm trying," George shouted back as he was batted in the face by a shiny jacketed book. "Hurry," said Eric. "We must get him out of here." With a great leap, Annie's dad hurled himself right onto Freddie's back and grabbed his ears. Using them as a sort of steering wheel, he turned the pig, who was still moving at quite some speed, and rode him like a bucking bronco through the door and back into the kitchen. Left alone, George looked around in wonder. He had never been in a room like this before. Not only was it beautifully, gloriously messy, as all the papers flying about in the air came gently down to the ground, but it was also full of exciting objects. On the wall, a huge blackboard covered with symbols and squiggles and colored chalk caught his eye. So a blackboard is another name for a chalkboard, which we don't use in schools as much anymore. Now we use whiteboards, but it's kind of that same idea. It also had lots of writing on it, but George didn't stop to read it. There were too many other things to look at. In the corner, a grandfather clock ticked slowly, the noise of the swinging pendulum clicking in time with a row of silvery balls suspended on a very fine wire that seemed to be in perpetual motion. Perpetual means it doesn't stop. On a wooden stand was a long brass tube that pointed up toward the window. It looked old and beautiful, and George couldn't resist touching the metal, which felt cool and soft at the same time. So there's the tube that he's talking about. Do you know where that is? Eric walked back into the room with his shirt untucked, his hair standing on end, his glasses at a strange angle, and a huge smile on his face. In his hand he held a book, which he had caught while riding Freddie out of the room. "George, this is incredible!" Eric looked thrilled. "I thought I'd lost it. It's my new book. I couldn't find it anywhere, and now your pig has found it for me." "What a result!" George just stood there, hand on the metal tube, staring at Eric open-mouthed. He'd been expecting to get into trouble for the damage his pig had wrecked, but Eric didn't even seem angry. He wasn't like anyone George had ever met. He never seemed to get angry no matter what happened in his house. It was all very baffling, confusing. "So I must thank you for all your help today," continued the peculiar Eric. Peculiar means strange, putting the lost book on top of a cardboard box. "Help?" echoed George faintly, who couldn't quite believe what he was hearing. "Yes, help," said Eric firmly. "As you seem so interested in science, perhaps I could tell you a bit more about it, by way of thank you. Where shall we start? What would you like to know?" George's mind was so full of questions that he found it hard to pick just one. Instead, he pointed at the metal tube. "What's this?" he asked. "Good choice, George. Good choice," said Eric happily. "That's my telescope. It's a very old one. 400 years ago, it belonged to a man named Galileo. He lived in Italy, and he loved looking up at the sky at night. At that time, people believed that all the planets in our solar system went around the Earth. Even the sun, they thought, orbited our planet. Orbit means goes around. But I know that's not true, said George, putting his eye to the old telescope. I know that the Earth goes around the sun. You do now, said Eric. Science is also about gaining knowledge through experience. You know that fact because Galileo discovered it all those years ago. By looking through his telescope, he realized that the Earth and all the other planets in the solar system orbit the sun. Can you see anything? I can see the moon, said George, squinting up the telescope, which was angled up to look out of the living room window into the evening sky. It looks like it's smiling. Those are scars from a violent past, the impacts of meteorites that crashed on the surface, said Eric. You can't see very far with Galileo's telescope, but if you went to an observatory and looked through a really big telescope, you would be able to see stars billions and billions of miles away. Stars so far away that by the time their light reaches our planet, they may actually already be dead. Can a star die? Really? Asked George. Oh, yes, said Eric. But first, I want to show you how a star is born. And then we'll take a look at how it dies. Hang on a minute, George, while I get everything set up. I think you're going to like this. Okay, so we're going to go back to page 33. That was the end of chapter 3. And read about our moon. A moon is a natural satellite of a planet. A satellite is an object that goes around a planet, like the Earth, which goes around the sun. And natural means that it's not man-made. You guys know about actual satellites that we send up in space that go around the Earth, but the moon is one that was made by nature, not by us. The average distance from the Earth to the moon is 238,854 miles. The diameter, which means the distance from one side of the Earth to the other straight across the middle, is 2,160 miles, or the diameter of the moon, sorry. And that's 27.3% of Earth's diameter. So if you take a little more than 3, almost 4, of the moons and lined them up, they equal 1 Earth across. The surface area, which means if we covered the moon with a blanket and then uncovered it and measured the amount of space that blanket took up, is about 0.04 times of the Earth's surface area. So it's pretty small. And its volume, the amount of space it takes up, is 0.02 times the Earth's volume. So basically they're showing you how much smaller the moon is. So the mass, 0.0123 times the Earth. And its gravity is 16.54% of Earth's gravity, which means if you were on the moon, you would weigh less than you would do on Earth. So if you're talking about weighing things this week when you do your measuring, that would be something that's different. All right, the first little moon circle says, the most obvious effect the moon's gravity has on the Earth is the tides of the ocean. The sea on the side of the Earth facing the moon is pulled harder towards the moon because it's closer. So if here's the Earth and the moon is over here, the ocean will be pulled just a little bit more towards the moon, which would bring us, the tides would come up. This raises a bulge in the sea on that side. Similarly, the sea on the side away from the moon is pulled towards the moon less than the Earth because it is farther away, and this creates another bulge in the sea on the other side of the Earth. Okay, the second moon says, even though the sun's gravitational pull is much stronger than the moon's, it has only about half the moon's effect on the tides because it's so much farther away. So the sun has a pull too, everything has gravity, but because it's weaker, it doesn't really affect it as much. When the moon is roughly in line with the Earth and the sun, the moon and the sun tides combine to produce the large tides called spring tides twice a month. So we go to the Oregon coast every year, and every year we look at the tide chart. And usually in June, there's a really, really good one where the tide will be way, way, way out so that we can go see lots of things, and that's when they're lined up. The next moon says, there is no atmosphere on the moon, so the sky there is black. The atmosphere is what the Earth has. It's where our air is that we can breathe, even during the day. And there hasn't been an earthquake or a volcanic eruption there since around the time life began on Earth. So all living organisms that have ever been on the Earth have seen exactly the same features on the moon. So the moon hasn't changed. The last moon says, "From Earth, we always see the same side of the moon. The first pictures of the moon's hidden side were taken by a spacecraft in 1959. So it wasn't until 1959 that we could go around the back side of the moon and take a picture to see what that looked like. Otherwise, we've only seen the same thing. Okay, in the circle in the middle of the page, it says the moon circles around the Earth in 27.3 days. The way the moon shines in the night sky is the same every 29.5 days. So every 29 and a half days, the moon will look the same. That's why sometimes we get a full moon twice in 1 month. Okay, next page, page 34. This page talks about light and stars. The first star says, "Everything in our universe takes time to travel, even light." Second star, "In space, light always travels at the maximum speed that is possible. It goes as fast as it possibly can, which is 186,000 miles per second." Now that's pretty tough to think about because we think about the track at the school. 1 time around, actually 4 times around is a mile. So 1 time around isn't even a full mile. So 4 times around would be a mile. And it took a few of you about 50 seconds to go 1 time around. So we're looking at maybe 5 or 6 minutes to run a mile. But this is telling us that the light travels 186,000 miles, so 4 times around the track, 186,000 times in 1 second. So that's pretty fast. The speed is called the speed of light. You guys, I'm sure, have seen shows with light speed in them. It takes light about 1.3 seconds to travel from Earth to the moon. And our sun is farther away from us than our moon is. So when light leaves the sun, it takes about 8 minutes and 30 seconds to reach us. So the light that we see from the sun is 8 minutes and 30 seconds old. It's very interesting. All right, in the dark box, it says, "The other stars in the sky are much, much farther away from Earth than the sun. The closest one after the sun is called Proxima Centauri, and it takes 4.22 years, so more than 4 years, for light from it to reach Earth." Wow, 4 years. All other stars are even farther away. The light of almost all the stars we can see in the night sky has been traveling for hundreds, thousands, or even tens of thousands of years before reaching our eyes. Even though we see them, some of these stars may not exist anymore, but we do not know it yet because the light of their explosion when they die has yet to reach us. So it just takes so much time. What we're seeing is old. It takes time for us to see what's happening right now. The last star says, "Distances in space can be measured in terms of light years, which is the distance light travels in 1 year. It's a long ways if it's going 186,000 miles in a second. A light year is almost 6,000 billion miles, around 9,500 billion kilometers. Okay, so that little picture on that page is Proxima Centauri, the closest star to the sun, to the Earth, after our sun. So it's pretty small. It's a good thing we have the sun, huh? All right. Come back later for chapter 4.